Hello lovelies, in this video we're going to be going through trigonometric equations for your A-level maths. Now, there are some tricky bits in here, so what we want you to do is to take it slowly. There are 15 examples worked through at 3 different levels, and what I want you to do is to pause after the question comes up, have a go at it yourself before you work through the answer.
Reviewing where we're up to so far with trigonometry, when we have a sine curve, we can find parts of the sine curve that are corresponding to certain angles. So, for example, in this question, we'll find the value of sine 235. So we get a sine curve. We find where 235 is, and then we have a look at the corresponding part of the curve. Now, this is going to be difficult to read off a graph, no matter how detailed it is, but using a calculator, you can type in sine 235. And it's going to give you the answer. And the answer for sine 235 is negative 0.8. And then there's some more decimal places to use an appropriate level of rounding. So let's say 2 decimal places for this. It'll be negative 0.82. Now, you should know this already, but what I want to show you here is actually multiple answers, which are 0.82. So firstly, at negative 0.82, we have our first answer, but then there's also a second answer a little bit further along the curve. It's at the same height. These are 2 answers, 0.82. Now, you can also have kind of positive versions of these. And so if we go through positive 0.82 up at the top, there's also going to be 2 answers here. Now, why is this important? So when we're asked to find the exact value of something, like sine 240, when we have a look at where 240 is on the graph, and we look down to get our answer, again, the calculator will give this to us. We know there's going to be 4 answers that use the same numbers. There's going to be another one on the kind of same axis, in this case, another negative answer, and then there's going to be the positive versions as well. Now, this is important because there's a limited number of exact values we should be remembering. So, which exact values should we know? Well, the degrees, we should know 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And 240 isn't in this list. However, what will be in the list is one of the other versions of it. And so this is what we're going to be looking at. And if we look at the graph, the one highlighted in pink right now, this is the one we're going to find. If we can find that one, then we can get the other 3 exact values. So what are the exact values? So we'll do a little table. What are the exact values for sine, cos, and tan? So we're going to have sine 0 is 0, cos 0 is 1, and tan 0 is 0. So these ones are normally the easy ones to remember. 90 also is quite easy. Sine of 90 is 1. Cos of 90 is 0. And tan of 90 is not defined. That's where we have an asymptote. So we don't have a value for that. So it's really the 30, the 45, and the 60 that's going to require the most remembering. Now at 30 degrees, sine 30 is a half. Cos 30 is root 3 over 2. And tan 30 is 1 over root 3. Then we have 45. Sine 45 is 1 over root 2. Cos 45 is also 1 over root 2. And tan 45 is 1. Then for 60, sine 60 is root 3 over 2. Cos 60 is a half. And tan 60 is a third. So how do we get 240? So if we look at the symmetry of a sine curve, the first kind of peak has symmetry through 90 degrees, and then the second curve has got symmetry through 270 degrees. So if we look at the distance, so 240 is 30 degrees back from 270. So the other answer at the same height is going to be 30 degrees in the other direction, which means this one's going to be 300. But our original one is obviously 240, that's what we're looking for. So what about the positive versions of these? Well, again, we look at the symmetry, and it's going to be 30 degrees at either side. So 30 degrees back from 90 is 60 degrees. and forward from 90 is 120 degrees. And so what we've got here is, we know that the sine of 60 degrees has the same answer as 120, and then the negative versions 240 and 300. So all we have to do is look at sine 60, which is root 3 over 2. And so if sine 60 is root 3 over 2, so let's write this in the colour, that means that sine 240 is going to be a negative root 3 over 2. And this is why we only remember a limited number of the exact values, because if you know what the key ones, kind of the first 90 degrees, then you can find the rest, because you can just use the symmetry of the curves to work out what they are. Because again, the same answers repeat over and over again. And again, sometimes they'll be negative, like in this case. Now, all of that is information that you should know already, but then here's the new topic. What about the cosec of 270? I want the exact value of that as well. So what exactly is a cosec? So we need some definitions. So cosec is the same as 1 over sine. So we've got the angles into this. Cosec of theta is equal to 1 over sine theta. We also have sec. Sec theta is equal to 1 over cosine theta. And we've got cot. Can we guess what cot is? It's 1 over tan theta. So these are our new definitions. We want the exact value of cosec 270. What we actually want is the same as 1 over sine 270 degrees. And the best way to work with these is to convert them into sin, cos, and tan. But you might be wondering what these things actually are. So I'm just going to do a rough sketch on the graph. We've got a sine curve here in red. Now I'm going to sketch out the cosec curve. Now, again, this is just a rough sketch, but cosec looks a little bit like this. It's kind of the opposite way around the curve. And it's like that both ways. And then when you get to places where it's equal to 0, 1 over 0 isn't something you can do. Then we have asymptotes at where you would have 0 values. So you'd have one at 0 degrees, you'd have one at 360, and you'd have one at 180 as well. And you can see the way I've sketched it, I have gone up to that asymptote. So again, this was just a sketch, but it shouldn't actually touch in that line. So it's going to look something like that. And, it's a much more complicated graph. You should be used to by now sketching sin, cos, and tan. So we're going to just work by converting these into sin, cos, and tan. So we want to find 1 over sine 270. So we bring up our exact values that we should remember. Then at sine 270, we're actually at the lowest point of the curve. There's only one answer at that height down there. So then that's going to correspond to the same number at the top of the curve at the other side. Now down here it's at -1. And you can see in the table that sine 90, which is where the positive answer is, sine 90 is 1. So sine of 270 is going to be -1. So it'll give us 1 over -1. And if we do that, 1 divided by -1 is going to give us -1. So that is our answer. So moving on to another example. This time we want sec 151 degrees. And we want it to 2 decimal places. So we don't need the exact values for this one. So we have to remember our definitions. Sec is equal to 1 over cos theta. Cosec theta is equal to 1 over sine theta. And the kind of important thing here is that you imagine that, well, cosec should line up with cos, surely, but it doesn't. It's the other way what you expect. Cosec is with sine, and sec is with cosine. And the last one is cot is equal to 1 over tan theta. Now, here we have a cos graph, because this one's related to cos. And again, if we just do a sketch of this, what it should look like is, it's going to be something like this. And we kind of got the opposite of the curves. And again, when we hit 0, we're going to have an asymptote, because you can't do 1 divided by 0. And on the cosine, between 0 and 360, there's 2 places where it hits 0. So you have 2 asymptotes in this case. So what we need to do now is transfer it into something we understand. So we can change sec 151 into 1 over cos 151. Now, cos 151 should give you negative 0.87. We want 1 over that. So 1 over that is going to give negative 1.14 to 2 decimal places. The important thing to mention here that is, if set 151 is negative 1.14, if you look roughly 151 is on this graph, then look at negative 1.14, it's going to be down here. Now you'll see that the pink line I drew for my sketch is nowhere near that green line. So really what's happening is that pink line is actually further down here. So it's like this. So again, what I'm drawing here is just a sketch, and actually the scale at the side is also going to change when you change it to 1 over something. So be careful with that, again, just a sketch. So for our next question, we're going to look at cot, and we want cot of pi over 6 radians, and we want the exact value. So I've got the exact values in the corner there. So we need to remember our definitions. Cot is equal to 1 over tan. Now we have a tan graph here, and again, I'm just going to give you a rough sketch to give you an idea of what the graph should look like. Now again, the asymptotes are going to be 0 for this graph. Let's draw those in, because it's going to help us to draw this graph. And a tan graph between 0 and 360 is at 0, 180, and 360. So our rough sketch here, and again, these scales aren't accurate. It's going to look something like this. It's almost the same as a tan curve, but it's kind of just flipped in the opposite direction. Now, this question wants the exact value, but it wants it with radians. When you remember your exact values, just remember the kind of radian versions as well. So we can have 0 radians for 0 degrees. Now, remember that a full circle in radians is 2 pi, and 90 degrees is going to be a quarter of 2 pi. And a quarter of 2 pi is going to be half of pi. So you can fit 4 halves of pi into 360. You can fit 4 90s into 360. 60 degrees is pi over 3. 45 degrees is pi over 4. And 30 degrees is pi over 6. So we want pi over 6 radians, which is actually going to correspond to 30 degrees. And the value of that, and I want the tan value for this, the tan value is 1 over root 3. So here's what we do. So cos pi over 6 is equal to 1 over tan pi over 6. And we know that tan pi over 6 is 1 over root 3. So we write it as 1 over root 3. Now, this is really bad for a fraction. We don't want to have a fraction over a fraction, 1 over root 3. So what we can do is, if you have 1 over something, that's the same as the reciprocal. Flip the fraction upside down. And so what we can do is we can say, well, this is equal to 1 over root 3 upside down, which is root 3 over 1. And if you have a fraction over 1, well, it's being divided by 1, and if you divide something by 1, it doesn't change. And so we can just write the answer as root 3. So cot pi over 6 is equal to root 3. How do we get there? We write cot as tan, and then we use our fraction skills to rearrange after taking the exact value from the table that we should be remembering. By the way, as an extra detail, if you're trouble with radians, like pi over 6, remember you can convert radians into degrees by thinking, well, radians is 2 pi in a circle, and degrees is 360 in a circle. To get from 2 to 360, we have to multiply by 180, and we don't want the pi anymore, so we have to divide by pi. So if we do this calculation, we end up getting 180 over 6, because the pi's have cancelled out, and 180 over 6 will give you 30 degrees. You can always convert radians into degrees as well as a strategy if you can't remember how your radians work. Just remember that radians, 2 pi in a circle. So now we're going to move on to trigonometric equations, not using sin, cos and tan, but using cosec, sec and cot. Our first equation is cosec x is equal to 2.128. Now, normally in this situation, you would do kind of the inverse of cosec. But what we want to do here is we want to actually get rid of the cosec altogether and change it to something we're familiar with, either a sin, a cos, or a tan. So what we're going to do here is we're going to find the reciprocal, the 1 over, of both sides. Because remember that cosec is 1 over sine. So on the left-hand side, cosec becomes sine. And on the right-hand side, we've got 1 divided by 2.128. And that's going to give us 0.4699. And let's leave it to 5 decimal places, actually. So let's put 2 on there as well. We've got the first 5 decimal places. We'll write our answer to 2 decimal places. We've got plenty of room here to avoid rounding errors. And by the way, if you're working out, I'm not aware of a reciprocal symbol. What you can do is you can write 1 over x, for example. And it just shows that you put in whatever the thing is that you have on that side of the equation, 1 over that. So, for example, cosec x is becoming the denominator and 1 is becoming the numerator. So now we've got rid of cosec. Our next step is to get x on its own. So we need to do inverse sine. That's typically written as sine to the minus 1 on calculators. It might also be written as sine as well. So sine and sine to the minus 1 cancel out, leaving just x on the left-hand side. And on the right-hand side, sine to the minus 1, 0.46992 should give you 28.03 degrees to 2 decimal places. Now we've got this answer. As always with trigonometric equations, there's a few things to check. The first thing to check is, are there any alternate answers? And so this is why I've got a sine curve drawn out. So we can think about where 28.03 degrees is going to be. Now, we can't read any accurate values off this. Again, I've got one drawn with the computer, and even this is too small to read accurate values off. We want to know just roughly where 28.03 is. So we know it's coming from, 0.469, it's going to be roughly around here somewhere. And so we can see on this line, you have 2 answers within 0 to 360. One of the answers goes down between 0 and 45, which will be the 28 answer. But then another answer comes down in between 135 and 180, and we need to find that answer. Now, with a sine curve, we can use a symmetry to get an actual accurate reading, because again, we can't read off an answer from I know it's going to be roughly around about maybe 140, but I don't know for sure. It's too small to read off for sure. Sine curves have got a line of symmetry through 90 degrees. If you just look at the bit between 0 and 180, so we're not looking anywhere past 180. There's another line of symmetry through 270. But again, that line of symmetry is just for the bit between 180 and 360. Looking at that line of symmetry, if our 28 degrees is coming in from the left-hand side, then using the symmetry, it's always going to be 28 degrees from the right-hand side. And the right-hand side starts at 180. So we do 180, take away our 28 degrees. What we're going to get is 151.97 to 2 decimal places. And a little pattern with sine is that the alternate answers, together, they should add up to 180. Because again, the symmetry is kind of working in between 0 and 180. So we have our alternate answer. Now, the calculator tends to give you the first answer that's closer to 0. It won't give you both. The next thing we need to look at is the range. Now, this range is in between 0 and 2 pi. If you have pi in your range, it's telling you that we want the answer in radians, and these answers are actually in degrees. Now, 2 pi is equivalent to 360 in degrees, so we want our range in between 0 and 360. And actually, we do have our answers in that range. So we're actually okay with the numbers we've got, but we just need to convert them into radians. So what we can do, degrees to radians, Degrees are in 360, radians are in 2 pi, from 360 to 2. Need to divide by 180. But we need the pi there as well, so we need to multiply by pi. So we do that calculation. I've got the 151.97 on my calculator from the last bit of the question. Let's divide that by 180 and multiply it by pi. And I'm going to get 2.65 to 2 decimal places. And that's in radians. We need to do the same thing with the first answer. No, I'm not going to use a 28.03. I want the full set of accuracy. So I'm actually going to do inverse sine 0.46992 again. So I get 28.02910 and so on. I've got the full set of accuracy. I don't want any rounding errors here. I'm going to divide that by 180 and multiply it by pi. And that's going to give me 0.49 radians to 2 decimal places. So that's the value of x. So really, looking back over the question, what's the difference between this and the previous trigonometric equations we've done? All it is we're just using cosec, sec, and cot instead of sine, cos, and tan. And how we deal with it? We just take the reciprocal to turn them back into sin, cos, or tan as a first step. Then the rest of it works the same way. Moving on to the next question, we have cot x is equal to negative 5.556. So our first step is to change cot into something more understandable for us. So we can take the reciprocal of both sides, and that will change cot x into tan x. And you can see I've got the tan graph drawn out ready. 1 over negative 5.556 is going to give us negative 0.17. And then we've got 998. There's a 5 after that, so let's write 999 to 5 decimal places. Again, writing more decimal places than we need, so we don't have any rounding errors later on. Our next step is going to be to get x on its own by doing the inverse of tan. And so on the left-hand side, we're left with just x. Now, with the previous question, the calculator I used was in degrees mode, and I got an answer in degrees. That meant that later on, I had to convert my answer into radians. Now, what you can do is, you can press the mode button on your calculator and change the setting to radians. And a little D symbol on your calculator screen should change to an R symbol. That means your calculator is now working in radians. So if then you do inverse tan negative 0.17999, in radians mode, it will do the conversion for you. And the answer I get is negative 0.17808. So actually, coincidentally, that's actually not too dissimilar from the number that I put in. Now, one problem with working with radians, it'd be more difficult to visualize where that number is on the kind of graph for radians. So we know that 360 is going to be 2 pi, 180 is going to be pi, so 90 degrees is pi by 2, for example. But how does that relate to 0.17? You know, it can be a little bit more complicated. So this is the reason why I might work in degrees. It's more understandable looking at the curve. One good thing is with tan, we know that tan actually repeats every 180 degrees. So if you already know the symmetry of what you're looking at, then you don't actually need to be looking at putting things on the graph. So all we need to do to get our other answer, if it repeats every 180 degrees, that's the same as pi. So what we can just do is add pi on to get the next answer. So negative 0.7808, let's add on pi, get our next answer, and get 2.96351 to 5 decimal places. So now we've got our alternate answer, we need to look at the range and decide if our answers are within this range. Now, it's in between negative pi and positive pi. I had a quick look at this earlier because that's how I knew I was working in radians, because pi is in the range. If we think about this being in radians, in degrees, this would be between negative 180 and a positive 180. Now, because the range is in pi, and we've got, 0.1 and 2.9, it can be hard to visualize if these are kind of in the correct range or not. So you might just usually think about pi. Pi is 3.142 to 3 decimal places. So you can see that our two answers here, they are actually kind of within pi. To help with that, one thing you might want to do is write the range in terms of decimals. So for pi, be negative 3.142 to positive 3.142. And obviously pi, that's been rounded to 3 decimal places for pi. That should be enough to kind of judge. Now, if you've got a negative part of the range here, you might think, well, are there any other solutions? Now, if we take the negative 0.17, if we take pi away from that, because remember, if times repeated every 180, we need to take 180 away from it or take pi away from it to get the next solution. If we take pi away, it's automatically outside the range because the range only goes up to pi itself. So we've got our two answers here. Last thing you might want to do is just make sure it's rounded appropriately. So we could just do it to 2 decimal places, 0.18 and 2.96. Could be our two answers to 2 decimal places. And so now with this question and the previous question, you've got a decision to make that if you're going to work in degrees or work in radians. Now, working in degrees tends to be more intuitive. It's linked to more things you've done in the past. It's easier to read values off the graphs. So it might be that you want to work in degrees if you're a little bit less confident with this. The benefit of working in radians, as you can see with this question, if we don't have that radian conversion at the end, we kind of skip a step. And so this version is much quicker to do. But you have to do a little bit of memorization with the kind of, the value of pi, with the kind of symmetry of the graphs, because radians are usually written, as kind of fractions in terms of pi, because that's the whole point, to get nice accurate answers. You don't really want a lot of decimal answers with radians. So, you have to be more confident to use a radian version, but it's faster. The next thing we're going to look at is you can have multi-step equations involving sec, cosec, and cot as well. Now, all these questions going forward are going to be in degrees, but just be aware that any time, any of these could actually be in radians as well. I'm just going to keep it to degrees. We're just focusing on the new content, in this case, having multiple steps. So this question, sec theta plus 50 degrees is equal to negative 1.031. So the first step, as usual, is we want to get rid of a sec. So we're going to take the reciprocal of both sides. So the reciprocal of sec is going to be cosine. And the bracket is going to stay as it is. Then we're going to have the reciprocal, the 1 over negative 1.031. And that's going to give negative 0.96993 to 5 decimal places. So now we want to get rid of the cos, so we can do the inverse of cos, and that will leave us with theta plus 50 degrees. And on the right-hand side, we want the inverse cos of negative 0.96993, and that gives 165.91 degrees to 2 decimal places. So again, we've got to the end of our equation almost, and we've got to the point where we've done the kind of inverse of the trigonometry and got rid of the trigonometry words altogether. At this point, we have 2 things to consider. We have our alternate answers, and we have the range. Now, it's useful to look at the range at this point because our range is in between 0 and 360, but that's the range for theta. We have theta plus 50. So let's find the range for theta plus 50, and we'll just add 50 onto it. So we'll be in between 50 degrees for theta plus 50 and 410 degrees. This is the range we want our answers in at this point of the equation. Then if you think about alternate answers, if we were at negative 0.96, that's really close to the bottom. And there should be 2 answers showing up. So the first answer looks like it corresponds to the 165.91. And the second answer is actually going to be quite close to it. And we can see this on either side of the 180. And you should be able to see the symmetry in the cos curve. It's right through the middle. at 180. So there's a few ways of doing this, but the easiest one, probably be consistent all the time. If we're going in 165 degrees from the left to get to the first answer, we're going in 165 degrees from the right to get the second answer. The right starts at 360. The 360 take away our 165.91, and we get the second answer. It's 194.08 degrees. And notice, when you're looking at a cos curve, your two answers, they should add up to 360 degrees. Now, both of those are within our range, between 50 degrees and 410 degrees. Think about even more alternate answers. You should know that these trigonometric curves, they repeat every 360 degrees. So if we take the 165 and we add on 360, we're going up to 525. That is actually outside our range. So adding or taking 360 from these, we'll get outside our range. We're only going to have these two answers. So next, we're going to take the 50 degrees away from both sides. And that's away from both of our alternate versions of the side. We take 50 away from everything. That means theta is equal to 115.91 degrees and 144.08 degrees. Then just check your range the last time. Now we want the range for just theta. That's between 0 and 360, and our answers are in between 0 and 360. So we've got our final answers. The next question is cot 2 theta equals negative 1.149. So this time, rather than adding onto theta, we're multiplying theta. But we're going to work the same way. First thing is to change the kind of trigonometry word into something we're used to. I'm going to take the reciprocal of both sides. And since cot is the reciprocal of tan, then the reciprocal of reciprocal is going to cancel it out and give us just tan. On the right-hand side, that means we're going to do 1 divided by negative 1.149. And that gives us negative 0.87. And let's do this to a few decimal places so we don't lose any accuracy with the rounding. So let's say 0.32. Let's do 5 decimal places. Then we want to do inverse tan. And that's going to give us 2 theta left on the right-hand side. And on the left-hand side, we're going to have negative 41 degrees. So 41.03 to 2 decimal places. Now, again, at this point, where we kind of got rid of the trigonometry, this is where we want to be looking for our alternate answers. So you think about a tan graphs repeat every 180 degrees. We get alternate answers by adding or subtracting 180. This is where we should be looking at a range. The range is in between negative 180 and positive 180. So if we take 180 away from negative 41, that's going to automatically take us outside our range. If we add 180 to it, though, that's going to give us our second answer. And that is 138.97 degrees to 2 decimal places. Let's look at those two numbers. Now, if you add the positive versions of those together, you're going to get 180, because again, they are a distance of 180 away from each other. Now, if we add 180 onto 138, again, that's going to automatically take us outside our range, because if we add 180 and our highest point's 180, if you add it to a positive number, it's going to be way too big. So we've got 2 possible answers. But again, thinking about the range, our next step is we're going to be dividing by 2. And we need to take that into account for the range. So if the range for theta is between 180 and positive 180, the range for 2 theta is going to be twice as big, in between negative 360 and positive 360. So we need to be thinking, a little bit bigger. So why don't we try adding 180 to this? That's going to give us 318.97 degrees. Then with negative 41.03, take 180 away from that now, and that's going to give us negative 221.03. So the point of this is don't just look within the final range. If you're only up to 2 theta in your equation, you can't use a range for theta. You have to use a range for 2 theta. And that's going to be twice as big. Because now we get to our next step. We have to get theta on its own, and we are dividing by 2. And even though the 318 and the negative 221 are outside our final range, if we divide them by 2, they're going to fit in. So now we have to divide everything by 2. So 2 theta divided by 2 is 1 theta. Negative 41.03 divided by 2, that's negative 20.5 degrees. Negative 221.03 divided by 2 is going to give us negative 110.5 degrees. 318.97 divided by 2 is going to give us 159.5 degrees. And the last one left, 138.97 divided by 2 is going to give us 69.5 to 1 decimal place. So you can see we've got 4 possible answers. Now we have one more one-step example left. We've got 3 cot theta is equal to 4. So what we need to do here is divide both sides by 3, get all the numbers onto one side. That's going to give us cot theta is equal to 4 divided by 3, which we don't need to work out, just leave it as 4 over 3. And then we've got cot, so we want to change that to something more understandable. Let's change it into tan by taking the reciprocal. The cot theta becomes tan theta. And you take the reciprocal of a fraction, it's going to flip upside down, so it'll be tan of 3/4. Now we just need to do inverse tan. Tan and inverse tan cancel out. And then the inverse tan of 3 over 4, use 0.75 there if you like, you should get 36.87 degrees. So with this question, it's not that we're going to do kind of adjustments at the end, but we have to, add or subtract something, multiply, divide something. With this kind of question, you do your kind of extra step at the very start. Now, we're still going to have alternate answers, and we need to look at the range. The range between negative 180 and positive 180. And we know that while all kind of these trigonometric curves repeat every 360 degrees, tan's special, and then it also repeats every 180 degrees. We can add or subtract 180 for alternate answers. Now, we add 180 to this, it gives us a positive number, we're going to add 180, our limit is 180, so we can't really add to it. We can subtract from it though, and we take 180 away from it, we're going to get negative 143.13 degrees to 2 decimal places. And then we take 180 away from a negative number. Again, our limit is negative 180, so we're going to go over our limit. These are our 2 answers within the range we've been given. Now, the hard question, in addition to having to get rid of sec, cosec, and cot, you also have multiple steps in solving the equation as well. So for a first example like this, we have 3 sec, then we have theta minus 60 degrees is equal to 4. So the first thing we can do is we can divide both sides by 3 and get all the number terms together. Leave us with sec theta minus 60 degrees is equal to 4 divided by 3. Then we can take the reciprocal of both sides, get rid of sec. So sec is going to become cos of cos theta minus 60 degrees, and 4 over 3 will become 3 over 4. Next, let's get rid of the cos. Let's do cos minus 1. That will leave us with theta minus 60 degrees is equal to, and cos to minus 1, and then we use 0.75 for 3/4. That's going to give us 41.41 degrees to 2 decimal places. So let's have a look at the range of answers we want. We want answers in between 0 and 360. That's a range of theta, and at the moment we're on theta minus 60. We take 60 away, we want a range in between negative 60 and 300. So we have 41.41. There's going to be an alternate answer here. So we think about where 0.75 is. We can see the location of our two answers. So we've got our first answer, we can see just below 45, which makes sense for 41. And our second answer, in a similar position on the other side. Symmetry of cos goes through the 180 in the middle, between 0 and 360. So if we are 41 in from the left, there'll also be 41 in from the right for the other answer. 360, take away our 41.41, will give us the alternate answer of 318.59 degrees. Now, looking at the range, that's outside the range, what between negative 60 and a positive 300. So that's too big. What we can do is we think, well, we've got a negative part of the range. What if we took 360 away from it? Because another bit of symmetry is always that these repeat every 360 degrees. So 318.59 take away 360 is going to give us a negative 41.41 degrees. And that is inside our range. We can go down as far as negative 60. If we took 360 away from the positive 41.41, we would get a negative 318.59. So again, these are going to be too big. They're outside our range. Now we can move on to our last step. We're going to add 60 degrees to both sides. Get theta on its own. That'll give us that theta is equal to, we're going to have 101.41 degrees, and then negative 41.41. If we add 60 to that, we're going to get 18.59 degrees. So they're the two answers, and they're in between 0 and 360. So they're within the correct range. The next example is 6 cot 2 theta is equal to 7. So we're going to start off by getting the number terms together. Let's divide by 6. Giving us cot of 2 theta is equal to 7/6. Then we're going to get rid of the cot. So let's do the reciprocal of both sides. Cot is going to become tan. And 7/6 will become 6/7. Now we can do the inverse of tan, leaving us with 2 theta is equal to the inverse tan of 6 divided by 7, which is going to give us 40.60 degrees to 2 decimal places. So now let's think about our range. Our range is in between 0 and 360 degrees, but that's a range for theta. At the moment in our equation, we're up to 2 theta. The range for 2 theta is going to be between 0 and 720 degrees. It's going to be twice as big. So our next step is going to be divide by 2. So any numbers that are too big are going to be shrunk down to bit. We also know that with tan repeats every 180 degrees. We can add and take away 180, get additional answers within the range. Now, if we take away, we're going to negatives, so we don't want any negative answers. But if we add 180, we should be able to get several answers that fit. So add 180 once, and we will get 220.6. Add 180 again, and we get 400.6. Add 180 again, and we're going to get 580.6. And add 180 again, and we get 760.6, which is outside of our range. So we're not going to write that one down. So we've got all of our possible alternate answers within the range. We can divide both sides by 2. And remember, every single possible answer needs dividing by 2. That gives us theta is equal to 20.3, 110.3 for the second one, 200.3 for the third one, and then 580 divided by 2 is 290. So 290.3. So again, we've got 4 possible answers. Again, to be thinking yourself, typically 2 answers for these questions. between 0 and 360. You've got to multiply by 2 in there, you probably end up with 4 answers. If you divide by 2, you're probably going to end up with 1 answer. The next example, we have 2 cosec a third theta equals 3. Again, our first step to get the number terms together, let's divide both sides by 2, giving us cosec third theta is equal to 3 divided by 2. 3 over 2 is a fraction. Let's change cosec into some trigonometry we're used to. Cosec is going to become, so sine a third theta is equal to, and then put the fraction side down for the reciprocal, 2 over 3. Now do the inverse sine, and do that to both sides, which will leave us with a third of theta is equal to sine to the minus 1, 2 divided by 3, which is 41.81 degrees to 2 decimal places. Now let's have a look at our range now we've dealt with the trigonometry. Our range is in between negative 180 and positive 180 for theta, but we don't have theta yet, we've got a third of theta. So the range for a third of theta is going to be a third of the size, we're going to divide by 3. It's going to be between negative 60 and positive 60 degrees. Now our answer is in that range. We need to check other possible alternate answers. Now 2/3 is about 0.6 recurring. It's going to be, somewhere around about here. And so the two answers between 0 and 360, we've got our 41 degrees, just before 45 on the graph, that makes sense. And then we've got our alternate answer. Now the symmetry on a sine curve is 390 degrees. If we just look between 0 and 180. So if we are 41 degrees in from the left-hand side, we're going to be 41 degrees in from the right-hand side. So 180, take away our 41.81, will give us the alternate answer, which is 138.19 degrees. But you'll notice that's outside our range. The next step is multiplying this by 3, and that's going to make it way outside the 180 range. Now, we can think that, this repeats every 360. Can we take away 360 from any of these and get an answer? If we take 360 away from the answer we've just got, we're going to get negative 221.81 degrees. Again, that's outside our range. If we do the same thing with a 41.81 and take 360 away from that, because again, all these graphs repeat every 360 degrees, we'll get negative 318.19 degrees. So all of these actually fall outside of our range. It looks like we're only going to have one suitable answer here. So our next step, we multiply by 3 to get theta. A third theta times 3 is 1 theta. And 41.81 multiplied by 3 is going to give us 125.4 degrees to 1 decimal place. And again, check the range at the end. That number is in between negative 180 and positive 180. The next question is cosec 3 theta plus 50 degrees is equal to negative 1.299. So the first step here is actually going to be getting rid of the cosec because nothing else kind of outside the brackets to look at. We can do the reciprocal of both sides. Cosec will become sine with 3 theta plus 50 degrees. Then the reciprocal of the next number is between 1 divided by negative 1.299, which will give us negative 0.7698 to 5 decimal places. Now let's get rid of the sign and do sine to the minus 1 to both sides. That will leave us with 3 theta minus 50 degrees is equal to, so then the inverse sine of our previous answer will give us negative 50.34 to 2 decimal places. So now we've done the trigonometry, we need to think about our range. Our range is in between 0 and 360. Well, that's a range of theta. We want the range of 3 theta minus 50. So 3 lots of 0 minus 50 is going to give us negative 50. That's the lower end of our range. And then for 360, you multiply that by 3 and then take away 50, we're going to get 1030 degrees. That's quite a large range actually going into the positive. But we are going to be dividing by 3 eventually, which will kind of again squeeze everything down. So let's think about all the possible alternate answers that we might want. So with negative 0.7, we're going to be, somewhere around about here. And the first answer we have is actually in the negative section of the sine curve. So the answer we have is the one I'm highlighting in green here. This is where the negative 50 is. So we need to be looking at the 2 answers that are further on. Now, we can think that if we add 50.34 from 0 back into the negative axis, for our first answer, if we think about the symmetry of this, then we're going to be 50.34 after 180. If you think about where 0 is, we've got a 0 at 0 and a 0 at 180. So looking at the symmetry of this through 90 degrees, we can see that we need to take 180 and add on the 50.34. And that'll give us the alternate answer of 230.34. Now, the best thing to do here is now we've got these 2 answers, is just to add 360 to get the rest. So we add 360 to the number we've just got, and we're going to get 590.34. We add 360 to that, and we're going to get 950.34. And we add 360 to that, we're going to get 1,310, which is outside our range. We're only going as far as 1,030. Then take the negative 50.34. We can add 360 to that. That's going to give us 309.66 degrees. And that's actually, if you look at the kind of the green coordinates I was looking at, that's the third one that I didn't look at because I knew I could get it in this way. Add 360 to that, we get 669.66. And we add 360 to that, we're going to get 1,029.66 degrees. That's just inside our range, actually. Now, out of all these answers, I can see I've got an odd number of answers. You tend to get an even number. And you think, well, you only get 2 answers. We've got a 3 feet, we'll get 3 times more answers. We're expecting about 6 answers. Well, the negative 50.34, that's actually slightly outside our range, so we're not going to have that one. So we're only interested in the 6 that are left. Now, there's 2 steps left, so we're going to be taking away 50 degrees first, and then we're going to be dividing by 3. Now, I'm not going to copy out each step one by one, I have to write 12 more figures. So I'm just going to do this all together on the calculator all at once. And we'll do the same thing to both sides. So 3 theta plus 50. If you take away 50, you get 3 theta. You divide by 3, you get 1 theta. That's why we're doing this. Let's take all 6 values one by one. 230.34, take away 50, divide by 3, and you get 60.1 to 1 decimal place. Then we take 309.66, take away 50, divide by 3, and you should get 86.6 degrees to 1 decimal place. Next one is 590.34, take away 50, divide by 3, and you get 180.1 to 1 decimal place. 669.66, take away 50, divided by 3, and we get 206.6 to 1 decimal place. 950.34, take away 50, divide by 3, and we get 300.1, 1 decimal place. And the final one, 1029.66, take away 50, divide by 3, and we get 326.56 degrees to 1 decimal place. And we see the really large numbers, like the 1029, even though it's well outside our range of 360, because we ended up dividing by 3, we can see it now fits in between the range of theta between 0 and 360. So we have 6 answers. Our final question is sec third theta, take away 10 degrees, is equal to negative 2.273. So our first step is to take the reciprocal of both sides, get rid of sec, and sec is going to become cosine if we do that. On the right-hand side, we'd have 1 divided by negative 2.273, which would give us negative 0.4399.5 to 5 decimal places. Then we want to do inverse cos to both sides. That will give us a third theta minus 10 degrees is equal to the inverse cos of our previous answer, which is 116.10 degrees to 2 decimal places. So now we need to check our range. We want in between negative 180 and positive 180, but that's for theta. So what do we do for a third theta? So a third of 180 will be 60, and then we're taking away 10. So negative 60 take away 10 will be negative 70 for the lower end. And then for a third theta minus 10, the upper end is going to be the 180 divided by 3, which is 60, take away the 10, which is 50 degrees. Got an answer in between negative 70 and positive 50, and the answer that we have is outside that range. But hopefully the alternate answer between 0 and 360 will be inside the range. So we had a look at negative 0.4, so that's roughly going to be around about here. And we have our two answers. So we have one answer in between 90 and 135, and we have one answer in between 225 and 270. Well, in between 90 and 135, we've got 116. That's that answer. That one's done. But what about the other answer? The symmetry is through 180. We know we've moved forward 116 from the left to get to our first answer. So using symmetry, it's going to be the same distance from the right. 360, take away 116.1. That's going to give us an alternate answer of 243.9. And that number is even further outside our range, but we are allowed some negative numbers. So what if we took 360 away from it? Because again, as always, these graphs, they always repeat every 360 degrees. So take away 360, we're going to get negative 116.10. And if we took the positive 116.10 and took away 360 from it, we're going to get a negative 243.9 degrees. So what's going on? Well, all four of these answers are outside of the range we're allowed. Now let's say we continued what's going to happen. So for our next step, we would have to add 10 to both sides and then multiply by 3. So let's say we just take the original answer, 116.10. So that's the one that's probably closest to our range. Perhaps a negative one's closer, actually. Let's look at that. So negative 116.1, if we take away 10, and then we multiply by 3, we get negative 378.3. Now that was the closest one to be inside our range, and it's far outside. We want in between negative 180 and positive 180, so we can't use that answer. And no matter what you do with these four answers, you're always going to get something that's outside of the allowable range. So this is a question that has no solutions. And again, always be aware that this can happen sometimes, especially when you're transforming theta, particularly when you're dividing it, you might end up with no possible solutions.
Ouch! This is why in some videos I explain scratches.